Hey everyone, I'm Raejetse, and I'll be talking about how we went about to construct a visual data set to study the effects of spatial apartheid in South Africa. And this was work that I did with my collaborators over a period of about 4 years. So just to give some context, solving problems is something that we machine learning researchers care about. However, the lack of ground truth labels actually prevents us from looking into problems that we might think maybe are more interesting or more pressing. And as such, we try hard to find ground truth labels so we can train these models and solve these problems somehow. So I'm just going to walk you through some common challenges that we find when we create ground truth data sets. So firstly, it's very labor intensive to create ground truth data sets. Given the first two images side by side, if you want to label if you want a ground truth of the image on the left, then what you would have to do typically is to label each and every pixel accordingly and coordinate this with a group of labelers. And for machine learning, you would need thousands, not thousands, but you'd need to coordinate a lot of labor, and you would need thousands of images, if not hundreds of thousands, for models which are data hungry. This becomes very financially expensive very quickly, and it requires a lot of updates. So if you're thinking about satellite imagery sort of data sets, then you would have to consider the fact that new buildings are being built every day even, and then if you want your data sets to be still up to date, you need to regularly update your ground truth labels. And after coordinating thousands and thousands of images of ground truth data, you would have to somehow evaluate that all those labelers were labeling the correct thing and everything is coherent. So those are some of the common challenges when you coordinate creating new ground truth data sets. And we also had a machine learning problem that we thought we could solve. We wanted to classify residential neighborhoods, according to their types in South Africa. However, we didn't have ground truth data to actually help us train our models. So we looked into different ways of creating this data set. And one of the ways we found was looking into pre-existing data sets that are used for other things, and seeing if putting them together would actually help us solve our problem. So just to give you some context, let me see if I can reduce this gallery mode here. Here. Just to give you some context, the Spatial Apartheid Act was an act that was passed during the apartheid era in South Africa. And this act literally reorganized how people were living in South Africa. And they moved a lot of non-European groups into these neighborhoods called townships. And this is what a township looks like. And on a satellite image over time, this is what a township looks like. So over the years, it has these visual characteristics that are consistent, and they're consistent. So townships are quite consistent. Similarly, if you look at this side over here, this is a suburb, and the visual characteristics have been consistent over the years, which all of these just served as motivation to why we think maybe a machine learning model could be able to solve this problem. So removing the effects of spatial apartheid is something the government of South Africa is grappling with, really. However, we see that there are modes of redress a little bit slow, in a sense that when you still look during apartheid, townships were underfunded, and as a result, resources like your hospitals and your schools were underfunded and they were overcrowded. So after apartheid, we still see resources like hospitals and schools still overcrowded and underfunded. So we just wanted to quantify how much of this is happening and analyze this over the years. However, we didn't know the extent of townships, for example, and we didn't know the extent of these townships for us to be able to demarcate a township and then analyze what's happening inside. So this is, we didn't know the extent at a certain point in time, and this is over satellite imagery. And then over the years, new buildings are being built, these townships grow. We still want to be able to track the growth as well. So just to give you some context of the visual characteristics at a closer level, the two images shown here, the one at the top on the left is a township next to a suburb, and at the bottom is a suburb next to an informal settlement neighborhood. So our goal was to be able to demarcate the extent of these neighborhood types using a machine learning algorithm and somehow create a data set by firstly creating a data set and then training on models. So the data sets that we had available, we had satellite imagery of years, over since 2006, all the way to 2020. We have a building data set that shows where there are buildings in the entire country. So we also had this last data set of what the land is supposed to be used for. So just quick points to take away here is that the building data set on the bottom left, this is the same township. The densely populated part of it is that same township that I showed you a few slides back. And then next to it is a much more wealthier neighborhood. It's a suburb. And then the yellow part here demarcates the township, and then the blue part demarcates the wealthy neighborhood. So given these data sets, we couldn't just use this data set at the corner here to train our machine learning models, mainly because, well, we tried, but then we quickly found that because there are some parts of, like, for example, here, this place here, this part here, doesn't look like there are buildings. And if we look into the label here, it looks like this is supposed to be the wealthy neighborhood that I mentioned, but then the model would be, like, it would get it wrong. There would be a lot of confusion trying to figure out how to label this part here. So we saw that while training our models and while iterating over the final data set that we thought could work. Similarly, another important fact is that I should mention is that in South Africa, before apartheid, there were townships and then there were suburbs, and then there were all these other neighborhood types. But then just after apartheid, the government then decided to merge townships with suburbs. So they merged under one class. So one important work that we had to do here was that we firstly had to disentangle these two classes by hand labeling, coordinating labelers around label where townships used to be, so that we don't get the confusion. Because the visual characteristics of a suburb is not the same as of a township. So if we're trying to train our models, it would be confused. So to create this data set that we have at the end, we had satellite imagery and we knew where all the buildings were. So what we did to also conserve the privacy of people, we just buffed where the buildings are supposed to be, replaced that point by a polygon. And then we did this throughout the whole country. After doing that, we looked at what the land was supposed to be used for, and then labeled those polygons by according to what the land was supposed to be used for, so that at the end we would know where all the buildings of village are, the buildings of farm are, and then the buildings of another class, for example. And after doing this, we just dissolved the individual buildings because it was individual polygons. So over 12 million polygons for that represent all the houses in the country or anything that looks like a building in the country. We just dissolved that according to our 12 classes at the time. And then after dissolving them, we just converted the sort of the geospatial data set into images so that we can train our semantic segmentation models that usually take in images and then masks as labels. So this would be just looking at a zoomed out version. This would be input, this would be the satellite image, and this is what the labels would look like over a part of Johannesburg, South Africa. So the yellow part would show where the township, the extent of the township is. The red part is where the informal settlements are, the blue are the suburbs, and so on and so on. But the white is background. So iterating over building models with these kinds of labels, we were able to get results that are converging. So given the initial data set, the initial ground truth that maybe we would have worked with the data that was given by the government, it's this one at the corner here. Just zooming into and just emphasizing the fact that if we were to build our models using that, we would have to account for when, like the parts we don't know about, the parts like this is supposed to be, this whole neighborhood here is a suburb, is a township, but then this had not been developed yet. So the label from the government would have just, labeled that as that part of the land, which looks like background on our machine learning model as a suburb. But then with the labels that we were using, we are able to mitigate those problems that might have been faced by those other labels. So we trained machine learning models on all of these data sets, including the final one that we have published. And we got very promising results, but then these are baseline models, opening the work up for other machine learning researchers to improve upon using this data set. So just looking at some of the results, when we had 12 classes of neighborhoods, the mean intersection of union on this task of neighborhood classification was more, it was more close to what's state of the art at the time. This was in 2018, actually. State of the art over 10 classes on a similar task was, and this just showed us that maybe we were on the right track. But then just to highlight some of the problems with labeling data sets, especially at a huge scale, everything in this blue boundary actually is of type suburb. There are some suburbs that have bigger yards, bigger houses, there are some suburbs that have smaller yards, smaller houses. Some have medium sized and all that. Just creating a data set and just deciding on the labels, because we decided on suburb being one class. There could be like a suburb type, subtype A, subtype B, subtype C, or so on and so on. But then we decided on suburb being one class, but then I'm just trying to highlight what some of the problems are with these labels that we decide upon. So depending on what kind of problems you're solving, and the kinds of models you're using to solve those problems, you should just be aware of, like you should really understand if the data set is really suited for those kinds of models, and be able to account for these kinds of problems when the machine learning models get them wrong. So some other things are, so this is a more, I suppose, maybe I'll just skip a few slides, but then I'll also talk about some failure cases of these models that we have. Some models would maybe be looking at certain characteristics on the images and then labeling them as a certain neighborhood type because of maybe some biases in the data. And it's really important to be able to just know that and thoroughly be able to look at that. So, for example, this would look at this walking path over here and label it as non-wealthy neighborhoods, or this part of the mountain here. This is a country-wide data set. So of course, there are different characteristics of these satellite images all across the country. But then perhaps the model could be looking at it and then labeling it as something else while it's not. So evaluating these data sets and these models thoroughly is something that is really needed when working with new data sets like these. So downstream tasks for data sets like the ones that we created, they would actually enable us, we hope they would actually enable us to track the growth of these neighborhoods that we're interested in. So this is actually part of a township in South Africa, and this is just how it's just been progressing over the years. So looking at a suburb, part of a suburb, this is what our ground truth would look like. Capturing these few houses that are here. And then this is just what the model has inferred over the years. But these are from our baseline models, and just publishing this data set, we hope to improve on these models and be able to capture all these, so that we can be able to estimate the growth of neighborhoods or the appearance of informal settlements or townships, and help mobilize the relevant stakeholders, help mobilize the needed services. But that is just the need for why we would, that is just one of the reasons to why we would consider creating data sets and using machine learning models to it. But then just some of the things that we've learned from this work actually is that, creating these data sets is it's a very labor intensive job. It's not an easy task, but then it has to be done. And if we are depending on using benchmark data sets, for example, they might not be able to capture some of these characteristics that I've just shown in some of these images that I've been sharing. And I'm actually quite excited about this conversation because it actually, given that this is something that I care about, and yes, let me just end there. I'm quite excited about it. Maybe I'll just leave some of the things for the